Hello, everyone, and welcome to today's Space Science Online class. I'm James, and this is the helmet that we made. Was it earlier this week? Was it last week? I can't really remember. I think it was earlier this week. Anyway, here's the helmet. I had a couple of these logos fall off here, and I had been using just kind of a little glue stick here. I'm going to use a little bit of a different technique to attach them now. Going to take some masking tape here and just kind of make a loop of it, put it on the back, paste it on. It's not super fancy. I'll do a little bit more later to make it more permanent. I'll find some better glue to stick it on, but this will do for now. Today, we are going to be talking some more about the solar system. Yesterday, the day before, we talked about planets and the different planets of our solar system and some of their moons and some cool stuff about that. Well, there's more in our solar system than just some planets and moons. There's a lot more going on. We're going to talk about that today. There we go. Not perfect, but it works. We had some more people send in pictures of their space helmets that they made. Here is Jackson. He made one here, and it looks like it's solid in the front, solid cardboard there, but he has view holes on the side that he can see through. That's a cool design. That's a cool design. Reminds me of the plane that Charles Lindbergh made to cross the Atlantic, where he could not see out the front. He had a periscope that he would look through, and with mirrors he could see around through the front of the plane. And here is one from Asher. That is a super cool design. I love the aluminum foil on kind of the mouth area of the mask. That really gives a nice vibe to it. And it looks like it might be flame out the top or something like that. That just looks really cool. And here is Ethan with that's really creative. He took paper and he kind of folded the paper up to give kind of like a crumply thing up top. He used, it looks like this little plastic window there is just built into the thing that he used to make the helmet. That's really creative thinking. I love that. All right. Bunch of people in the comment section saying hi. Gerard's asking, can we get our own helmet? Gerard, if you weren't with us on Monday when we talked about making space helmets, if you go to youtube.com/the Delphian School, or just find Delphian on YouTube, every single one of these online classes, everything we've done for the last 2 weeks, the 230 classes that we did throughout the spring, those are all available on our YouTube channel, and you can watch through that, and we talk about how to get started and some ideas on where to go with it. Evan suggests hot glue for the mission patches. Yes, I love that idea. I think that is what I'm going to do. I just didn't have a hot glue gun with me the other day, and I don't have one with me right now, but that is a really, really great idea. All right. Hello to everyone that's saying hello. And we are going to jump into this. If you were with us in our first season of online classes back in the spring, some of this is going to be review material for you. I say stick around and watch, because it's not the first time I've covered it. It's not the first time I've looked at or learned about it. But every time I review the information, I understand it better. I understand it more. I'm connecting it with more things that we've talked about and more things that we've learned. You could read the same thing 5 times over at different parts of your life, and you're going to get more from it each time, or something different from it each time. So that's what we're doing here. Okay. So solar system, more than just planets. There's a lot going on here. The first part that we're going to talk about is the asteroid belt, which is the part of space that between the orbits of Mars and Jupiter. And this is where most of the asteroids in our solar system are located. And here's a kind of an illustration of our solar system. That inner blue line, that is the orbit of Mercury. That red that yellow bit in the center there, that's our sun. So here's Mercury, here is Venus, and here's Earth's orbit, the third one out. Fourth one out is Mars, and then fifth planet out there, that is Jupiter. You can see there's a lot of space, excuse me, a lot of space between Mars and Jupiter. All of those green dots are asteroids, and you can see why they call it an asteroid belt. It looks like a solid belt of material, like a belt that you have around, you know, the waist of your pants. It's not as thick as all that. Yes, every single one of those dots does represent an asteroid. Even if stuff is big, space is bigger. So we've probably all seen Star Wars or some other movie that shows a ship flying through an asteroid field. We see it in Guardians of the Galaxy, a ton of movies. And they're like dodging between this thick cluster of asteroids all around them. If you make one wrong turn, you're gonna hit a rock and explode. That's not what a real life asteroid belt is like. A real life asteroid belt, you could go flying through it 100 times without even any kind of direction or aiming, and your chances of hitting anything are so small. Missions that NASA has where they do go to an asteroid in the asteroid belt, they need to plan very carefully to actually get a spacecraft close enough to an asteroid to observe it. There's just there's a lot of space out there. These red dots are also asteroids, but those are showing asteroids that come to the inner part of our solar system, and the green ones are the ones that stick around in the asteroid belt. They don't really float in closer than that. Okay. Some more comments here in the Q&A section. Aubrey suggests Scotch tape. Yeah, that's a really good idea. Scotch tape is great. You know, put it on, it's pretty much invisible after that. Milo says he likes any kind of space thing. I know, you are one of our most attended viewers on all these space things. Evan said he made a laser gun. That is amazing. And Gerard asked, how many asteroids are in the Milky Way? Okay, I don't know how to answer that one. So the Milky Way is our entire galaxy. That is the 100 billion, the 100 million stars that are orbiting in our galaxy here. I don't know how to answer that. I can give you some estimates on how many asteroids are in our own solar system that are orbiting our own sun. We have some estimates of that in some later slides here. So thank you for asking that question. Your mind went where mine went. I want to know how many, what are we talking about? Evan's asking, what are the blue dots? So those blue dots, we're going to come back to those in a few minutes here. You'll notice that they're in two clusters on Jupiter's orbit. There's one cluster here, then there's another cluster over here. We're going to learn about those soon. I'm glad that you noticed that because I did too, and I wondered, what are those? We're going to find out. All right. Gerard asked another question. The asteroids between Mars and Jupiter are called the Kuiper Belt, right? Okay, no. So there is something called the Kuiper Belt, and we're going to talk about that in a few minutes. The asteroid belt is between Mars and Jupiter. The Kuiper Belt is further out. It's past Neptune. I'm glad you asked about that. We're going to learn about that soon here. So here's another illustration of asteroids in our inner solar system. Here's the sun. There's Mercury orbiting. There's Venus, Earth, and then let's see, Mars. There's Mars right kind of at the inside edge of that thick colored band right there. And then there's Jupiter is here and Saturn a bit farther out. So again, you can see there's this thick belt. There's asteroids all over the place in our solar system, but they really like to hang out between Mars and Jupiter. And then again, here's clusters on Jupiter's orbit. There's one cluster here, and then there's Jupiter, and then there's another cluster over there. Why is that? We're going to learn about that. So the asteroid belt is estimated to contain between 1.1 and 1.9 million asteroids that are bigger than 1 kilometer in diameter. So that's just the big ones. I would call an asteroid that's 1 kilometer in diameter or bigger, I would call those big. But millions of smaller ones as well. I can't say how many millions, but there's got to be so many of them beyond counting. And the best we can do is estimate because they're small and it's dark out there in space. So you would need to send spacecraft into the asteroid belt looking very closely in order to try to get a better estimate of how many there are. Okay, so someone had mentioned the Kuiper Belt. This is a different belt of asteroids, a different band of them in our solar system. It is a region beyond the orbit of Neptune, and it has a lot of comets and asteroids and other small bodies that are made largely of ice. So a lot of, I mean, like all those asteroids in the asteroid belt between Mars and Jupiter, these are rocky. They might be made of loose dust or some thicker, stronger rock, or they might have a lot of metal in them. Scientists know that there are asteroids out there that are very, very rich in metal. One asteroid that they found, there is more gold on that one asteroid than has been mined in the entire history of mankind. On one asteroid. It's a big asteroid, but still, there's some really fascinating objects out there. So these objects here in the asteroid belt, the inner asteroid belt, are rocky. And the objects that are out past Neptune there's a lot more ice involved. There's a lot more ice on them. Because even if there were ice on these inner asteroids here, the sun would have boiled that ice away a long time ago in the 4.5 billion years that this asteroid belt has been kind of just chilling out there past the orbit of Mars. It is cold out there, but close enough to the sun that ice would boil away. All right. And Evan asks, isn't there a theory that the asteroid belt is the remains of a planet? I have heard that said. The total combined mass, if you took all the asteroids in the asteroid belt and you put them all together, it wouldn't form a very big planet. But what scientists think happened is that maybe those asteroids were going to go and maybe become part of Mars or be absorbed by Jupiter or something like that. Maybe form into a smaller planet like Mercury or something like that. But Jupiter is flying around pretty close by. And as Jupiter is orbiting, its gravity is really strong and it kind of jostled stuff around too much. And so it couldn't stick together. Mars is far enough away from Jupiter that it was able to form its own planet. But Jupiter has a lot of influence on the orbits within our solar system. All right, we're talking about the Kuiper Belt. Okay, so here is an image of this kind of yellow ring out here. That's the Kuiper Belt. You can see here is the inner solar system, Mercury, Venus, Earth, Mars. That's all right on the inside there. You can see that white cluster, that white ring on the inside. That's the asteroid belt. Then you've got Jupiter, Saturn, Uranus, and Neptune. Then out past Neptune, here you have Pluto, and here you have the Kuiper Belt. There's a few other objects marked on here. So here's Pluto. Here's another dwarf planet, a small Pluto-like planet, Pluto-like object named Eris. And Haumea and Makemake are also two large objects out there. I think they're smaller than Pluto, but they're big enough that we know that they're there. They're very interesting to us. This yellow line here, this is not the orbit of Pluto. This yellow line is the path of a spacecraft that was launched a few years ago called New Horizons. And the whole mission of New Horizons was to launch from Earth and zoom out into the outer solar system, and it made a very close pass to Pluto. And it took a lot of really close-up images and did a lot of measurements and readings and stuff like that. It's the closest we've ever been to Pluto. It was meant specifically to go there and to study it. And we learned a lot from that New Horizons mission. All right, so the Kuiper Belt So far, more than 2,000 Kuiper Belt objects, or KBOs, have been cataloged by observers, but they represent only a tiny fraction of the total number of objects that scientists think are out there. Astronomers estimate that there are hundreds of thousands of objects in the Kuiper Belt region that are at least 60 miles wide or larger. Wow. Hundreds of thousands of objects that are at least 60 miles wide. There's a lot of stuff out there. That's just a lot of stuff. All right, Katya's asking, is there ice on Mars? If there is, you could heat it up and purify it so that we could drink it. Yeah. There is water on Mars. They do know that there is water ice below the surface of Mars. They've found that. And they have found evidence that there was liquid water on the surface of Mars at some point in the last few billion years. Okay, so that's not very precise. Like, was it yesterday? Was it 10,000 years ago? Was it a billion years ago? That's hard to say. But they've found rocks on the surface of Mars that geologists know the only way a rock could form like that and have that shape is if it was in liquid water. So that's really cool. So yeah, we could take that ice, that water ice on Mars, and we could melt it, we could purify it, we could drink it. Definitely. There's water ice on the moon as well. So we don't need to bring all the water that we're ever going to need with us. We're not going to need to bring all the oxygen that we'll ever need with us, because you could take that water, separate out the hydrogen and the oxygen, and you could have oxygen and also some hydrogen. There would be hydrogen left over from that process. All right. Gerard asks, why are there asteroids between Mars and Jupiter and not between any other planets? That's a fantastic question, and that's a good physics question. That has made scientists and astronomers really think about that and look at what are the physics involved, why. There are other asteroids around there. I think closer in than that, and it's close enough that the sun would be able to pull them in. But they're kind of caught in a tug of war between the sun and Jupiter. They're not close enough to Jupiter to get pulled into Jupiter. They're not close enough to the sun to get pulled into the sun. There's a nice little equal part in space. So Kuiper Belt, why is it called the Kuiper Belt? It's because of this guy, Gerard Kuiper. He lived from 1903 to 1973, and he was the one that was first discovering this. Let's see if I have some more. No. So he was the one that was first making these observations of this stuff out there past Neptune, and put together the idea like, hey guys, I think there's probably a ton of stuff out there. So they named it after him. Out past the Kuiper Belt is another place called the Oort Cloud. And this is a region of the solar system far beyond the orbit of the dwarf planet Pluto, in which billions of comets move in nearly circular orbits unless one is pulled into a different orbit by a passing star. So we're talking way out there. You thought that the Kuiper Belt was pretty distant? Oort Cloud is even farther. All right, so I'm going to lean in and peek really closely to my screen. Do you see that yellow ring in there? Really small, right at the center of the screen. That's all our planets. That's the Kuiper Belt. That little tiny yellow ring is the Kuiper Belt that we saw that was so far away from our sun. You keep going out further and further and further, and you've got the inner Oort Cloud and the outer Oort Cloud. Millions of comets. Let's see, what did I say in that last slide? Millions or billions? Billions. Billions of comets out there. They're made mostly of ice. There's some other dust and rock and stuff involved, but a lot of it's ice. It's not close enough to the sun that ice evaporated away. So they're out there and they're orbiting very gently. This is, these are the leftovers of the formation of our solar system. Our solar system was a giant, ball or region of gas that started to come together to form the sun and the planets. And there's just a lot of leftover stuff. When you're done building something out of wood, you've got stuff left over. You've got sawdust from where you sawed it and, screwed in screws and stuff like that. You got sawdust and bits of stuff left over. Those are asteroids, those are comets. So it makes up the Asteroid Belt and the Kuiper Belt and the Oort Cloud. All right, and Gerard is noticing that Gerard Kuiper, my name is Gerard. Wow, yes, Gerard. So maybe one day there will be a discovery in space named after you. That would be amazing. I could say, I know that guy. All right. Oh, Gerard asked, what does AU mean? Did I have that somewhere in here? Did that show up? Let me look back at my slides real quick. Well, it may have showed up on one of my slides. AU stands for astronomical unit. So unit is one piece of something, right? An inch is a unit of measurement. A second is a unit of time. An astronomical unit is used to measure distances within our solar system. So from the sun to the earth, that is one astronomical unit. It's about 93 million miles. And it's a handy unit of measurement used to measure stuff within our own solar system. Like we can say that Jupiter is, I'm forgetting right now, it's like 5 AU from the sun, 10 AU from the sun. I think it's somewhere around there. So we can say, go from the sun to the earth and do that 10 more times and you are 10 AU away. All right. So all these comets are out there gently orbiting in the Oort cloud until something happens that makes their orbit shift. It might be that they're floating out there gently and a passing star coming by way far away. The gravity is just enough to just pull that comet a little bit and shift its orbit, and that would make it come towards the inner solar system. All right, here's another picture of the Oort cloud. You can see here, maybe there was a comet living out here near the outer edge of the Oort cloud. Something came by and kind of pushed it or pulled it a little bit, and its nice circular orbit turned into this long kind of oval orbit. This is called elliptical, a big oval instead of a circle. And that means that for much of its life, it'll be out here in the Oort cloud, but every so often it'll go zooming in towards the sun and it'll get pulled back out again and it'll rest out there in the Oort cloud. It'll be moving pretty slowly out here. And then the closer it gets to the sun, the faster and faster and faster it'll go, zoop, and then it'll go slow again out there. So the Oort cloud is estimated to have 2 trillion objects. We're dealing with big numbers here, big numbers. All right, I'm going to pop into the Q&A section here really quick. All right, Katya said that AU is also a college in Indiana. It stands for Anderson University. Awesome. Good. Gerard says miles is a unit of measuring for using roads. Yes, very good. But miles is way too small to measure distance in space. You're right. You know, just from here to the sun is 93 million miles. We start adding so many zeros, it becomes kind of useless. It's like trying to use centimeters to measure the distance from, you know, the Earth to the moon, or from Boston to Miami or something like that. Using centimeters, using inches, that number quickly becomes not very useful. So instead of saying it's a billion miles away, we can say it is this many astronomical units. All right. Good. Gerard is asking, what's the difference between a comet, a meteor, and an asteroid? All right, I'll take that up. I'm going to pop out of the slides here for a moment. So an asteroid is a more rocky thing in space. An asteroid and a comet could be the same size, but you would call them different things depending on what they're made of. A comet is more icy. You can think of it as a giant, dirty space snowball. A asteroid is more of just a space rock more dust, more metal, more rock. Asteroid, comet, more ice involved with it. A meteor is what we're going to call an asteroid or a comet if a comet came close enough to hit the Earth, where it actually hits the Earth. You look up in the sky and you see a streak of fire in the sky as the asteroid comes into our atmosphere and heats up due to the friction of hitting air. That is a meteor. You'll call it a meteorite once it's actually through the atmosphere and it falls to the ground. Let's say this bottle was an asteroid out there and it's flying around through space. It comes and it hits the Earth. Oh, there, we have the Earth behind us. I can do a little kind of demonstration. And it comes in, here comes this asteroid, and it hits our atmosphere and it starts getting really hot. It starts burning up. At that point, you're going to call it a meteor. And then it lands on the ground. You find it, you pick it up. You're like, oh, look at this. And splashing water everywhere. The lid was loose. So you pick it up. You're like, wow, look at this. This rock came from space. This is a meteorite. That's what you call a meteor after it touches the ground. All right. Shanna asks, what does a space nerd name his dog? Shanna, I don't know. What does a space nerd name his dog? I'll have to wait for your answer in the Q&A section. Comet! I like it. I was going to say Pluto, but Comet works great too. Okay, good. And Milo's asking if we can talk about the formation of stars. Yes, we're going to cover that in one of our space science classes next week. All right. Continuing on with our slideshow here. So why is it called the Oort Cloud? Well, it's because of this guy, Jan Oort. He lived from 1900 to 1992. And here he is at a telescope working away. This guy did a lot of observation of our solar system and of the universe. And he was the one that put together this idea, like, you know what? These comets that come by every once in a while, we only see a few of them, but every once in a while a comet shows up that we've never seen before. There must be a place where all these comets are coming from. There must be a place where they are born or made, or they're living, they hide, they wait, something. And then every once in a while they come towards the sun and we can actually see them. So he figured out, if you can see a few of them, and we're always finding more, there must be a lot out there. So they named that region of space after him. Smart guy. If I were to discover something, I would hope that people would name it after me too. If I'm like, hey, I found that there's an entire section of space that is just made of stuff made of cheese, I would want them to call that the James Cloud or the James Belt or something like that, the James Cheese region. Okay. Tanisha asks, can you please answer our question? I'm afraid I missed that question here. Let me scroll up and see if I can find it. If I can't find it, just ask the question again. Just type it in again, and I will be happy to answer that question to the best of my ability. Oh, there it is. Are you Mystery Doug or Sid the Science Kid? Neither and both. I'm a little bit more Bill Nye, the science guy, and maybe some Neil deGrasse Tyson. I love both of those astronomers. Carl Sagan was a great educator and astronomer from the 1970s and 80s and later. And so I like to, I've been influenced a lot by their teachings, but I'm all them and none of them. I am James the Science Dude. James the Science Guy. I don't know. We'll figure out a name. Next, we were talking about Lagrange Points. I love Lagrange Points. This is just a fun little thing that happens with physics in space when you have two objects, two bodies that have gravity. So there are 5 points relative to two objects in space where the gravitational pull between them is balanced. So let's say we're looking at the sun and the earth, right? The earth has gravity. We all know this because here we are. We're all experiencing gravity from the earth right now. The sun also has gravity, way more gravity than earth. And that's what makes the Earth orbit the sun. Well, if you had two friends and you had one friend on this side pulling your arm this way and one friend pulling your arm this way, if there would be a point where their pulling would be equal, where you wouldn't be pulled to the left, you would not be pulled to the right, you would stay put even though you're being pulled in both directions. There's a point of balance, of equality there. That is the L1 Lagrange point, Lagrange 1. And there's that point between the sun and the Earth where you're right in the middle, man. The sun's not stronger than the Earth's pull, and the Earth's not stronger than the sun's pull, so you just kind of sit there. L2 is if you go past the Earth, away from the sun, there's a point where the gravity, again, is equal. You're not being equally pulled or pushed one way or the other. You can just float there. If you go all the way past the sun to approximately where the Earth's orbit would be on the far side, that is the L3 Lagrange point. Again, equal gravity. You're not being pulled one way or the other. And then if you go off to the side, again, on the orbit, but ahead or behind of where the Earth is orbiting, that's the L4 and L5 Lagrange points. Here we have another map, and this shows the push and pull of gravity. I say push of gravity. It's always a pull of gravity. But we can see here's this point right between the Earth and the sun where these white lines are showing the pull or the effects of gravity from these things. And you can see there's this little spot right there in the middle where it's equal. And over here with the L2, and on the far side with the L3. And then look at L4 and 5. There's these large patches of space there. It's not even like L1 and L2, those Lagrange points are kind of small there. You need to park something very carefully to make sure it doesn't float away. Look at 4 and 5. It's not a parking space, it's an entire parking lot out there in space. That's amazing. I'm gonna leave that graphic up for a moment as I catch up on the questions here. Aubrey asks, what is an astronaut's favorite drink? I don't know, Aubrey. What is it? I'm going to let you ask that one. And while we're waiting for Aubrey here, Tanisha asks, does it rain diamonds on one of the planets? Yes, not one of the planets in our solar system, but there is a planet outside of our solar system where scientists have been able to figure out, because of how big the planet is, because of what's in the atmosphere, because of how hot it is, they know that diamonds are formed and rain down. It's really, really, really cool. There's some crazy cool stuff in space. Aubrey says a root beer float. That's the astronaut's favorite drink. A root beer float. I like that. Shanna says that sounds impossible. It is impossible on Earth, but if you have a planet with enough carbon in the atmosphere, all a diamond is just the element carbon compressed and formed in a certain way with a lot of heat and pressure. And you can have a very carbon-rich atmosphere with a lot of heat and pressure in that atmosphere, and that would form diamonds. All right, Gerard is asking, can it rain acid on Earth or anywhere? Yes, so acid, not like you step outside and it touches you and your skin instantly burns away. We don't have that on Earth, but we do have water on Earth where the balance of the chemicals and the balance of what's in the water is more acidic. There's more acid in it. There's stuff in it that's going to dissolve away certain things, where a human body would not survive well in that kind of water. There's the wrong combination of stuff in it. Okay, so I want to leave that up, sitting up there for a little bit. We're going to move on here and show that, so a Lagrange point, one of these 5 sections between any 2 objects in space where the pull of gravity is pretty much equal. So that means that there's Lagrange points between the sun and the Earth, also between the Earth and the moon. And if something was orbiting the moon, let's say a spacecraft orbiting our moon, there would also be Lagrange points between those two things. Now, the spacecraft might be so small compared to the moon that the Lagrange points don't really matter at all. They're way too small to be useful. But you've got the L1, 2, 3, 4, and 5 Lagrange points between Sun, Earth, and you've got your Earth-Moon Lagrange points. So between the Earth and the Moon, there's the L1 Lagrange point. Between us, past the Moon, is the L2 Lagrange point. On the opposite end of the Moon's orbit is L3, and then 4 and 5 off to the sides. So think about our solar system. Think about all the planets orbiting the Moon, orbiting the Sun. Think about Saturn with its 82 moons that we learned about 1 or 2 days ago. And every single one of those moons, between the Moon and Saturn, there will be those 5 Lagrange points for each of the 82 moons orbiting Saturn. It can get really complicated out there, but really a lot of opportunities can come from that. One idea is if you wanted to take a satellite and park it up there orbiting our planet so that you don't need to use a lot of fuel. All the satellites up there orbiting our planet right now, most of them need some fuel to keep themselves up there. The space station, it fires its thrusters, I think like once or twice a week, just to keep its orbit, because it's not at a Lagrange point. It's not perfect. Its orbit is slowly getting closer and closer to the Earth. So every once in a while, they need to boost it back up so it doesn't fall into our atmosphere. But you can take a satellite and park it at the L1 Lagrange point between us and the Moon, or at the L4 between, off to the side of the Moon. And it would stay there with very, very, very little effort and very little additional fuel needed. There's a telescope launching hopefully later next year called the James Webb Space Telescope. And this is going to be like the Hubble, giant space telescope. It is 10 times more powerful than the Hubble. It's going to get some amazing images and some amazing science that we're going to learn a lot from. And they're going to park it at that, at the Earth, I think it's at the Earth-Sun L2 Lagrange point. Because what that will do, it'll be very stable at that point out there. And also, the Earth is going to be blocking the sun. So there's not going to be the sun shining on the telescope, making it hard for it to see everything. It's going to be in a shadow. It's going to be darker, and we'll be able to see more of space. Why is it called a Lagrange point? It's named after this guy, Joseph Louis Lagrange. He was French, and he was born in 1736, and he died in 1813. And back then, he figured out, just with math, like, hey, guys, if you got 2 things in space, this is going to happen. Trust me on this. The math checks out. One of the best demonstrations of Lagrange points, especially the L4 and 5, these ones that follow the orbit of the planet ahead and behind of it, are these things called Trojan asteroids. Asteroids belonging to one of 2 groups which orbit the sun at the same distance as Jupiter at the Lagrangian points ahead of and behind Jupiter in its orbit. So if you attended Remy's online class here yesterday, where he was talking about the Trojan War and the giant wooden horse that the Greeks put together to sneak their soldiers into Troy and open the gates on the inside, that's kind of what's happening around Jupiter. You have these asteroids just kind of hanging out and sneaking along with it. Here's the orbit of Jupiter going along. And here you can see these teal bits ahead of and behind Jupiter's orbit. Remember I was talking about earlier, these, it's not just one spot there. There's these parking lots, there's wide regions of space where stuff would be pretty stable there. Well, you can see those shown exactly here, ahead of and behind Jupiter in its orbit. That is so cool. It's such a perfect demonstration of what we've just been talking about. You can see it with your own eyes. You can see the more pink asteroids being shown, some of them will float between those Lagrange points. They're not stable in one or the other. And they kind of migrate from this one to this one, and then over here, and then back. And so here's the L3 and 4, sorry, the L4 and 5 Lagrange points there. But again, there's another Lagrange point on the far side of an object's orbit. So over here is the L3 Lagrange point. So something can float over here, park and hang out for a little bit, and then it'll float over here and hang out for a little bit, and then it's migrating between those 3 points. I love this graphic. What's next? Okay, so Trojan asteroids. So astronomers have agreed to name these asteroids after people from the Trojan War of Greek mythology. The asteroids orbiting near the L4 point of Jupiter are named after characters from the Greek side of the war, and those orbiting near the L5 point are named after the characters from the Trojan side of the war. So go back and watch Remy's online class yesterday about the Trojan War. Those names are going to, if you start looking at asteroids in those two clumps there, you'll recognize those names. There's one last group there. So you've got, here's Jupiter, you got your Trojans over here, you got your Greeks over here, even though they're all called Trojan asteroids. I guess they had some disagreements on the naming there. There is a name for that third group out there that kind of hangs out and migrates between the L3, L4, L5 points. So over at the L3 point, those are called Hildas. Not because of anyone from the Trojan War, but because the dude who discovered or did the math and figured out that there would be a bunch of asteroids there, his daughter's name was Hilda. So he wanted to name them after his daughter, which is cool. I have a daughter, I would totally do something like that. That's the end of our slides. We have about 1 minute left in our slot today. I'm going to leave this graphic up because it's mesmerizing. And the more you look at it, the more you can observe, the more you can pick up. I'm going to look at the Q&A section here for a little bit. Jackson asks, is there another name for the moon than just the moon? Yes, so different languages call it different things. Boy, I had this in my slides from yesterday. It's called Luna. It's called Selene. I think Selene was the Greek name for it. Selene was the Greek goddess of the moon. There's more names. I can't remember them right now, which is one of the reasons I kind of use slides in these to make sure that when there's these smaller bits, these smaller facts, like how many objects are there in the Oort cloud, I can't remember everything all at once, but it's in the slides, and I want to make sure that you guys get the right information. All right, Gerard asks, why do we need an L4 and 5 if they're not in the same straight line as L1, 2, and 3? Cool. I love your questions. Let's see. Let's go to this one here. So you've got 1, 2, 3 in that straight line. And then 4 and 5, you know, they're still, it's the push and pull. It's the equality of the gravitational pull between the sun and the earth that create those little parking lots out there. Without those two objects in space, the L4 and 5 points would not be this gravitationally equal part. So yeah, they're still part of that same system there, which is why we're gonna give them the L4 and 5 bits. We are almost out of time. That is correct, Shanna. Gerard asks, are all or some of the discoveries in space named by the same person who discovered it? Not every single one. You know, we don't call Mars by the name of the guy who discovered Mars in the night sky for the first time. It's kind of up to the people who discover it. Do they name it after themselves, or do they name it after someone else, like this guy that named these Hildas because it's named after his daughter? And there's some things, like the Milky Way, it was named not after the person who figured out that we're in a galaxy, but the name was generally agreed upon by the scientific community. How things have been named in space has changed over the years. There is now a group of astronomers that when they discover something new, sometimes there's pre-existing rules about how to name something. When they discover a planet orbiting another star, there's a system already agreed upon and already in place on what the name for that planet is going to be. So next week, we're going to talk about stars. How are stars formed? What is their life cycle like? How do they die? That sounds really rough, but it's just part of a natural cycle of the universe. Stars form and they live for a certain amount of time, and then sometimes they explode. Sometimes they just kind of like fade away. We'll learn more about that. All right, I'm going to stick around in the Q&A section here for a couple minutes after I cut the feed. But if you have questions, if you have pictures of your space helmet that you made that you haven't sent in yet, a topic that you would like us to cover, let us know. events@delphian.org. That's the email address that you can send any of those items to. We will see that. We will respond to them. Thank you so much for joining today, and I look forward to seeing you next time.